When solving a system of linear equations, elimination is an excellent method if you notice that both of your equations have opposite terms. Notice in the top equation we have positive 2x, and in the bottom equation we have negative 2x. Since each of the equations have opposite terms, elimination is a great method. But next we need to make sure that all of our terms are lined up. So looking to the left of the equal sign, notice how the x's are lined up, the y's are lined up, and to the right, the numbers are lined up. We're ready to use elimination. All we need to do is add. So let's add straight down. 2x minus 2x is nothing. Our x's have been eliminated. Negative 5y and 10y make 5y. Bringing down the equal sign, then combining what's on the right. 6 minus 16 is negative 10. Now to solve the equation and get y by itself, we'll get rid of multiply by 5 by dividing by 5. Y equals negative 10 divided by 5, which is negative 2. Now that I know y, I need to grab one of the original equations. It does not matter which equation you grab. You'll get the same answer either way. Now I can replace the y in that equation with negative 2. Simplifying the left side, negative 5 times negative 2 is 10. Next, let's move that 10 to the other side by subtracting 10. 6 minus 10 is negative 4. To get rid of multiply by 2, let's divide by 2, and x equals negative 2. Another way you could write the answer is as a coordinate, negative 2 comma negative 2. Because if I graph both of these equations, this is the point where the lines intersect. Let's take a look at one more example. If I want to use elimination, remember, you want to make sure your terms are lined up. So I can see that my x's are lined up, my y's are lined up, my equal signs are lined up, and then the numbers there on the right. Next, I would like to have terms that are opposites. We're really close, 5y and 5y. We'd like one of those to be negative 5y. An option we have to make 5y and negative 5y is to rewrite one of the equations. We can rewrite an equation by multiplying both sides by a number. So I'm going to multiply both sides of the equal sign there by negative 1. So multiplying 4x times negative 1, I get negative 4x. 5y times negative 1 is negative 5y, and 5 times negative 1 is negative 5. I'm going to recopy the other equation. Notice, now that I've rewritten that top equation, we have opposite terms, negative 5y and 5y. Now that these are opposites, we're set up for elimination. We're just going to add each of the columns. So negative 4x and 8x make 4x. The negative 5y and 5y are 0, so we've eliminated the y's. I'm going to bring down that equal sign, and then combining negative 5 and 25, I get 20. To get x alone, I'll get rid of multiply by 4 by dividing by 4, and I find that x is equal to 5. Now that I know x, I'm going to go back to one of the original equations. It does not matter which equation I go back to. I'm going to grab this one, and then I'm going to replace the x in that equation with the number 5. So substituting in 5, then to solve, I'm going to simplify the left side. So I got 40. Move the 40 over, so 5y equals negative 15. Divide by 5, and I find that y is negative 3. Once again, if you would like, you could write your final answer as a coordinate, which would be 5 comma negative 3. The reason you can do this is if I graphed those original equations, this is the point where those two lines would intersect. In the first two examples, using elimination was fairly straightforward. Both equations either started off having opposite terms, or in that second example, to create opposite terms, all I needed to do was multiply one of the equations by -1. In both of these examples, we're going to have to work a little bit harder to get opposite terms. We're going to need to multiply one or both of the original equations by a number so that we get the same amount of x's, but one positive and one negative, or the same amount of y's, one positive and one negative. So let's start with example number 3. To use elimination, we want opposite terms. Notice that the x's are not opposites. -4x and directly below it -2x are not opposite. Let's look at the y's. -3y and +7y. Those are also not opposites. But we could force the x's to be opposites. If I took that second equation and multiplied it by -2, then that would become +4x, -4x and +4x. So let's multiply -2 through that second equation and leave the top equation alone. So multiplying -2 through, -2 times -2x is +4x. And then -2 times 7y is -14y. And -2 multiplied by 14 is -28. I chose to multiply this equation by -2 because that's the number that is going to make my x's opposites. Now we can see that our x's are opposites, -4x and +4x. So we're ready to eliminate. So let's just add straight down, and the x's drop out, and -3y and -14y is -17y. -6 and -28 make -34. To finish solving, I'm going to divide by -17 to get rid of multiply by -17. And I find that y is equal to +2. Now that I've found y, I can grab either one of the original equations, substitute 2 in for the y, and solve for x. So simplifying the left side, -3 times +2 is -6. Numbers to one side, letters to the other. We do that by adding and subtracting, so I'm going to add that 6 to the other side. I end up with -4x is 0. To get rid of multiply by -4, I'm going to divide by -4, and 0 divided by -4 is 0. So the solution to example 3 is x is 0 and y is 2. If you want, you could write your final answer as a coordinate because this is the point where the graphs of these two lines intersect. I haven't left myself enough space, so coming over here for example 4, trying to solve with elimination, we're looking for opposite terms. And notice the x's are not opposite and the y's are not opposite. But we can multiply these equations by a number to create opposites. It doesn't matter if we try to make opposites out of the x or out of the y. I'm going to go with y. So for -5 and 3, if I could make one of them 15 and the other one -15, then we would have opposites. To make +15y, I need to multiply that top equation by 5. And to make -15y, I need to multiply the bottom equation by +3. Multiplying all of the terms, everything on one side and the other side, by 5, I get negative 40x, and then 5 times 3y, a positive times a positive is positive, so 5 times 3y is 15y. What I do to one side of the equal sign, I have to do to the other. So 5 times 2 is 10. Again, I selected 5 because I wanted positive 15y. Now let's multiply the other equation by 3. So 3 multiplied by negative 7x is negative 21x. 3 times negative 5y is minus 15y. What I do to one side of the equal sign, I've got to do to the other. So I'm also multiplying the 17 by 3. And 3 times 17 is 51. By multiplying by 5 and 3, notice our y's are opposite, so we're ready to eliminate. So combining negative 40x and negative 20x make negative 61x. The 15y and the negative 15y eliminate the y's, and then 10 and 51 are 61. Divide by negative 61 to get x by itself, and we find out that x is equal to negative 1. Now that I know x, I'm going to go back to either one of the original equations. It does not matter which equation you grab, and replace the x with negative 1. To solve, I'm going to simplify the left side, so negative 8 times negative 1 is 8. Letters to one side, numbers to the other by adding and subtracting. So I'm going to subtract over 8. 3y equals negative 6. Divide both sides by 3. And y is equal to negative 2. If you'd like, you could write your final answer as a coordinate. The reason you can do this is if I graphed those two equations, this is the point where they would intersect.